hold on. Let me flip the logo over. There we go. All right. So gonna do this one live because there's a lot of stuff. There's a lot of information out there, going around, going on, and everything. Hold on. There we go. All right. So yeah, let's talk live. Here we go. Got a ton of news and information to go over between PS5, technical seminar, Lost Soul Side got a trailer. Let's see here. Why is there two? Okay. Exodus, which is a new, I guess it's like a spiritual successor to Mass Effect, I do believe. And then we got way more information on Intergalactic, the new one from Naughty Dog. So I figured, why not? Let's do it live. So what do I want to jump into for? Oh, and I got to bring it up on the other screen. That would help. Hold on one second. OBS. Boom, boom, boom. Whoa. Hold on. I got on the wrong inputs. My sources. What? Wait a second. And of course, everything goes all highwire. Identify. That's number one. Okay, this is main. Why is that not going over to... What? I clicked the wrong one? Oh, I clicked the wrong one. That's why. There we go. Okay. Okay, yeah. Okay. We'll start off with Lost Soul Side. I was gonna go like Exodus and all that stuff, but yeah, let's just let's go with this one first. Let's see what we got here. Is this was this South Korea? Because I know we had like 2 games that were being made in South Korea. Lost Soul aside, or was this the China one? Chinese developer. Okay. Once again, this is another one of these Chinese games. I don't know. I think South Korea can maybe make games a little bit better than China. I definitely, even after playing 2 hours of Wukong, I played another hour, 40 minutes off stream of Wukong. I was just like, I don't give a shit. Like, I ran through probably 4 boss fights of it, and it was, and 3 of them I did on the first try. I was just like, eh. So China's not really, I don't know. Like, I know Marvel Rivals is blowing up big, but also I'm pretty sure that on the console is made actually in the UK, not China. So it's a different development system for Marvel Rivals. Yeah, let's see. Taking into Fortune 40p. This is probably the biggest difference in between like what we're doing over here. In America and Canada and all that, and actually, I'd say, in the West versus the East, as I always like to say, in the East they're not afraid to beautify the characters. Where, in the West, I will 100% agree with that. We'll get into, actually, yeah, I want to leave that on the table because we'll get into that a little bit later on talking about that stuff. Right. Okay. This is this one is supposed to be like Final Fantasy meets Devil May Cry. That looks very DMC. I think this is the one that was started by like one person. Going to PS5 and PC at 25. Wishlist now. Next year, really. PlayStation. And again, too, this is like the initiative. Yeah, so China Hero Project. This is actually, so the funding for this, pretty much this is like Japan taking all the sales profits for out of China, which is probably a good thing because China has been ripping off every single industry that there is for years and years now. And so PlayStation is just like, you know what, screw it. We're going to help out these Chinese developers get their games, made, but then make it so the Chinese market doesn't, basically, because China already has Tencent. They don't need the gaming market. They already own bits and pieces of everything. They screw up bits and pieces of everything. It's the reason why we haven't. I would say it's a big reason why there is certain stuff from software that hasn't been made yet, and I will still stick behind. It's because of Tencent, because Tencent has tried to own a good chunk of the gaming industry in that sense. But yeah, this looks this definitely. I'm seeing a lot of. It's hard for me to get hyped up for something like that. I mean, the gameplay, this looks smoother than Wukong. I'll give it that. And the fact that this, I'm pretty sure, was started by one person. I might have the wrong game on that. But yeah, this looks very much like Devil May Cry combat mixed with Final Fantasy exploration. I mean, cool. There's not much here to be seeing, and the fact that it comes out in 2025 and we're not seeing any story of like who are these characters, what's going on with it. I mean, you're just getting body language off, but there is no voiceover or anything. I mean, I guess keep an eye on it, but yeah, it comes out next year. Dante and Noctis, Dant, Devil May Fantasy. Thing of promising creator a chance to bring his vision. Yes. Okay. Yeah. This game has been in development for 5 million years. A few years, and the fact that they don't have a giant development team says a lot about everything. Okay. So we have a Digital Foundry video, and then we have the actual tech seminar. We'll go with tech seminar from Sony Interactive Entertainment HQ. Very cool. 7 hours ago. Mark Cerny. Let's go.
Hi, I'm Mark Cerny. Today I'd like to do a deep dive into the technology behind our latest console, PlayStation 5 Pro. Now, to be clear, this is a bits and bytes talk with no game footage at all. Principally, I'll be explaining what we put into the PlayStation 5 Pro GPU and why.
Okay. If they're doing this at all, it means that the PS5 Pro is underselling, and they're doing something to be like, okay, we need the console to sell a little bit better than this, so let's get some bells and whistles out there. Let's make this thing sound really fancy. The problem is there is really no games that dropped with it that makes you go, I really need this. Now, I think if you have a PS5, especially if you have a PS4 Pro, you should 100% upgrade to a PS5 Pro because you have basically all your same library, except for it's going to run a hell of a lot smoother, and you have upscaling built into it. Like, if you're waiting for the Pro Series to Pro, or the Pro console, then now's the best time than ever to do that. But yeah, this is definitely screaming like Sony is being like, why isn't this console selling? Why aren't people upgrading? It's been 5 years.
Historically, every 7 or so years, there's enough interesting technological advances that we release a new generation of console.
Interesting, 7 years, because usually the rule of fives, but I guess Sony's trying to bring it to the 7-year mark. If we go by 7 years, then that means it's going to be like, what, 2032, 2033, something like that is when the PlayStation 6, could potentially be coming out.
Like PS3 or PS4 or 5. These introduce broad improvements like a more powerful CPU and GPU and also significant new capabilities.
Interesting, they're using the slim model of the PS5, not the original.
Like compute shaders on PS4 or the SSD and 3D audio on PS5. Games can then be created with the whole console feature set in mind. It allows for a tremendous step up in what the player experiences.
Ratchet and Clank, Spider-Man.
It does take a certain amount of time for game creators to get up to speed with that new console. But we're all prepared for that because the benefits of moving to that new generation are so high.
And this is the reason why we always have test units and developer kits and such that go out to all the different studios. Kojima, he's that famous picture of Kojima with the towel over top of the system, most likely developing for the Pro. Although I still say it could be a PlayStation 6 that they're starting work this early for, to make sure that when the PlayStation 6 drops, because everybody's going to be like, why do I need a PlayStation 6? It's going to be the same thing all over again. So if you can run full real, my rule of thumb for the next generation is, I'm going to say it's probably going to have to do 120 FPS and run full realistic, or people are just going to be like, nope, not doing it. I think it's that the next console is probably going to be the last generation too.
Recently, there have also been console releases during a generation, like PS4 Pro and now PS5 Pro. These are much more tightly focused, typically on the GPU. And what developers are making are improved versions of games, never dedicated games. So targets for Pro consoles are very different. First, the work that needs to be done by the game creators for the Pro console needs to be kept to an absolute minimum. They already have a lot of pieces of hardware they're supporting.
Yeah, especially if you're not a first-party company. You're talking Xbox S plus the X, maybe Xbox One, PS4, PS4 Pro, PS5, PS5 Pro now, possibly even the PC setups and everything, which is infinite amount of setups there. Maybe even also the Switch, if you can fit it onto the Switch and everything. If you're first party, it's just like that's the one thing that I've heard from multiple different developers who are talking on different podcasts and everything, is that if you are first party, it makes it so much easier to work for, because now you're just like, okay, here's our box, here's what we got to make this work for. Then maybe a year later, boom, PC, you can drop it onto there, do that thing. So yeah, 100% of that.
Don't want to add much to that burden. And second, those tightly focused improvements need to be pretty significant. The games have to play noticeably better. One of the trickier aspects of console design is that creating a console is roughly a 4-year journey. In order to launch PS5 Pro in 2024, we were actually trying to work out the key feature set in 2020. In other words, at a time before PlayStation 5 had even been released. And of course, what we came up with was the set of improvements we've been calling the Big Three. First, there's that larger GPU. The idea is simple. Pretty much anything the game is rendering on PlayStation 5 should get a lot faster on PS5 Pro. Second, there are the upgrades to the ray tracing hardware. Those games that move to the new architecture should get a substantial additional speed boost. And finally, there's AI-driven upscaling. The upscaling technology is a combination of custom hardware for machine learning and an AI library called PlayStation Spectral Super Resolution, PSSR for short, that runs on top of that hardware. PSSR analyzes the game images as it upscales them and can add quite a bit of crispness and
For those that are still working on a GTX card on their computers, this is literally the equivalent of going from a GTX to an RTX card. And well, yeah, I guess I was going to say, but we already had ray tracing built in, which is true. We can already do ray tracing, but now we have the upscaler. So, well, consoles is always behind the PC. It's true. But the thing is a lot of people don't even know how to run a PC. They need to be able to hit the button and make it work. And so with the majority of people on that side, yes, then the PlayStation 5 is like that. That's your box. That is your console. That is your window into doing everything that you've seen for years on the PC. So if you're wondering of like, well, this, that, and the other thing, when it comes to PSSR and upscaling, well, yeah, the upscaling thing. It's not a cheap way of doing things either. It's the upscaler is there to just increase the fidelity of your visuals, so it just makes everything look so much smoother.
Detail. Now, to do all that, we needed a larger and more capable GPU. This is what we used on the original PS5. It's a GPU from our partner AMD.
Yeah.
More specifically, it's an RDNA 2 GPU, meaning that it used the second generation of AMD's RDNA 2 technology. The GPU has subunits called workgroup processors, or WGPs. PlayStation 5 has 18 of them. The GPU on PS5 Pro is much larger. It has 30 workgroup processors.
Wow.
It's also what I'm calling a hybrid RDNA GPU, which is to say, it combines multiple generations of RDNA technology.
Hmm.
The base technology for PS5 Pro is somewhere between RDNA 2 and RDNA 3. I'm calling it RDNA 2.x. As I'll shortly explain, that choice makes it much easier for game developers to port their games to the new console. Ray tracing uses what I'm calling future RDNA technology. It's roadmap RDNA that's well past the feature set today.
What I would be interested to know, because I have not heard any developers talk about this, it's just because PSSR is so brand new that I haven't seen anybody really get into the technical side of things, other than just like, it looks so much better and it works. I would be very interested to know from developers' side of things, how hard it is to optimize the game engine to run between something like PSSR and DLSS, if there is a significant like optimization different thing. Is it different coding, or is it different systems in place or whatever, or is it just interchangeable?
It's showing up here first. And machine learning is...
And the reason why I'm saying that asking that is because if it's harder to interchange going from, say, PSSR to a DLSS, that would probably take more time on PC to get games ready for PC. So if they are first-party titles from PlayStation, to try and bring them over to be optimized for like a DLSS, like Final Fantasy just did this with Rebirth. What's the time frame, how long it takes, because then we can figure out, oh, okay, so if the game comes out at the beginning of the year, can we expect it maybe by Christmas time or something, or does it take 6 months maybe to finally get that over to the PC? And then you can do everything on the PS5, have your awesome adventure on the PS5, and then turn around and mod it or whatever on the PC if need be or want. That's what's the time frame on that? That's basically the biggest question.
Custom, or to be more specific, it's custom enhancements to RDNA. And just to be clear, I may say machine learning or ML or AI today. These are just different words for the same topics. Now, to support that GPU and the overall plan for PS5 Pro, we needed faster memory and we needed more memory. The faster part is pretty simple. The system memory on PS5 Pro has a bandwidth of 576 gigabytes per second, which is 28% higher than PlayStation 5.
That's good.
More memory is needed for a variety of usage scenarios on PS5 Pro. Integrating PSSR takes memory. A few hundred megabytes are needed for its internal buffers.
A few hundred megabytes? Wait, it's not a few gigs, it's a few megabytes. Whoa. Huh. Because DLSS takes, like when you kick that on, usually your VRAM kind of shoots up to the roof by at least like 3 or 4 gigs of VRAM. So if this is going into megabytes territory, damn, that's very efficient then. That means the PlayStation 5 Pro has a lot of room for growth, and you have a lot of wiggle room when you're trying to actually optimize the game settings and everything. That's very good because you can make the game engine dance a little bit better on the screen.
Adding ray tracing takes memory.
Yes.
Ray tracing uses data in the form of an acceleration structure that can easily be a few hundred megabytes in size.
Right.
And if the game is targeting higher resolution, that can take memory as well.
Yes.
That can be just a little memory, perhaps if the maximum rendering resolution is being increased a bit, or it can be a lot of memory, for example, if the game is targeting 8K. So we supply over 1 gigabyte of extra memory to the games, and we do this in the same way we did on PS4 Pro, which is to say we added a hidden slower RAM. We used DDR5 for that, and moved a lot of the operating system into it. That keeps games, which need high bandwidth, in fast memory.
Okay, so essentially the PS5 Pro is kind of what your modern day up-to-date PC is built on, is like an AMD build. Unfortunately, and the reason why I say unfortunately is because Intel and RTX NVIDIA cards work the best for gaming. Like overall, 100%. Like PS5 Pro looks very good, but you will get the best performance on the market have any single setup that you look at is going to be an Intel card, 13th, 14th gen processor with a 30 to 40 series graphics card of an NVIDIA. If you run that, you're going to have the most bang for your buck that you can possibly get. It's like the top thing on the market. And anybody who's arguing, or anybody who would argue that, then they don't play around with settings. They just slap it on ultra mode and go from there. Even people that I watch on the regular, or channels I should say, that I watch on the regular that try and talk about optimization on the game engines, even they do that. They slap it on ultra mode and they're just like, yep. And then sometimes Digital Foundry does optimization videos, but like I said, if you're really trying to get the most bang for your buck, go with that setup on PC, and then you optimize the game engine down. You don't need ultra settings, because ultra doesn't. It's actually diminishing return. You can go with high settings on most stuff, and then you can actually upscale using like something like DLSS, which is the reason why PSSR is so great, because it upscales also. And essentially, what Mark is saying here is that the PS5 Pro essentially does that same thing.
Getting back to the hybrid GPU, I'd like to take you through each of the three aspects of our strategy, beginning with the choice of RDNA 2.x as the base technology.
Okay.
AMD is continuously updating the GPU technology. RDNA 3 has more functionality and is more performant than RDNA 2. There's even a chance to bring in future RDNA technologies like we did with ray tracing. If we're making a new generation of console, of course we want the latest and greatest, but with a mid-generation release like PS5 Pro, we also have to consider that a single game package needs to support both PS5 and PS5 Pro. That limited the degree to which we could adopt.
Good. Drop the PS4 already. Let's get on to the PS5 5 years later, for fuck's sake, and let's actually support the current gen that we're in instead of last gen. And if you are on the PS4, upgrade. Like, seriously, you're holding like all the PS4 is doing. I love the PS4. I still have it sitting over here on the desk and everything. I just had Bloodborne running on it at 60 FPS. It's still an amazing machine for its time, but it is time to retire it and get on to the current gen. It's 5 years later. Fuck's sake. By the time we're like a year into the PS5 Pro, we should be 100% done with the PS4. It should be retired fully from production and everything.
RDNA 3 technologies. For example, games have something called shader programs that execute on the GPU. A game might have over 100,000 of them. If we adopted RDNA 3 technologies to the extent that code compiled to run on PS5 Pro wouldn't run on PS5, that would mean creating two versions of each executable piece of code. One for PS5, another for PS5 Pro. That's a massive complication.
Yeah.
The game package needs to be patched to include that second version, and then the game needs to either selectively load just the appropriate version, or find room for both versions in system memory. It's a big burden for the developers.
It's a big mess.
Consequently, PS5 Pro uses a version of RDNA that I'm calling RDNA 2.x, which is bringing in a number of features from RDNA 3, but not anything that would cause that degree of complications. For example, aspects of vertex and primitive processing are faster on PS5 Pro. That's from bringing in parts of the geometry pipe from RDNA 3 that are powerful, but either trivial for the game to adopt, or better yet, invisible to the game program.
So, one thing that pops in the brain is PS3, and it is possible to run PS3 coding and everything on the PS5, which everybody's always said that. It is possible to do it. The thing is it won't run perfect. And I've seen a couple of videos where people are like, oh yes, I tore this down and I'm a coder, I'm a hacker and this and that. And I got the PS3 games running on the PS5 because I took it out of the box and I hacked into it and I did the coding and all that stuff. It's like, sure, but does it run perfect? Because if there's glitches and it doesn't run great, then everybody's going to be like, and they're just going to threads and Twitter posts and and YouTube videos and Sony did it again, they screwed something up and all that stuff. So they have to make it run perfect. No artifacting, no weird colors, no lighting issues, all that stuff. So And even if you look at like the PS3 emulator on the PC, there is shit that goes wrong in it all the time. So even the people who have like infinite amount of resources, a ton of time in their hands, they are just focused on making this thing work. Even they are having a hard time making that work. So before everybody starts going, Sony bad, they don't want to do back compat. No, it's like it's hard to fucking make it work the correct way. I've actually played around with the emulation and everything with PS3, and yeah, just trying to get those things pinpointed in for every single game. It takes you like an hour, 2 hours, 3 hours, and sometimes it just doesn't work because it just doesn't communicate that well with the hardware or whatever. I'm not a coder, so I don't exactly know all the ins and outs of all the ones and zeros and everything, but I can tell you from working with the game engines, trying to make them run on emulation software, essentially. That's what Mark's kind of talking about here. Like you'd have to emulate one, well, not really emulate. Emulate's the wrong word. Make essentially kind of two versions of the same operating system work on each for each title. Make the game engines work with that and everything. Yeah. It's such a pain to do all that.
One thing I'd like to clear up is the erroneous 33.5 teraflop number that's been circulating for PS5 Pro. That number isn't anywhere in our developer docs. It comes from a misunderstanding by someone commenting on leaked PS5 Pro technical information.
Wow.
Part of the confusion comes from RDNA 3 architectures having double the flops of RDNA 2 architectures. Now, to quote Digital Foundry on this topic, it's a nice little bonus to have twice the flops, but it doesn't do anything like double real-world performance. So there's a certain amount of flopflation going on here.
Wow, Mark is calling out people who are talking through leak stuff. Damn, that's okay. All right, that's kind of cool that Mark is calling that shit out of like, no, these people don't know what the fuck they're talking about. They're trying to make a YouTube video to sell you on that they know more than what Sony does. And Sony's over here actually working with the system. And yeah, essentially this is what I've been saying. Like they have a little piece of information and they blow it out of proportion, dramatize and everything. And yeah, no, it's because they're trying like hell to start drama and get views. And people click on it.
We did not bring in the doubled floating point math from RDNA 3 because achieving that bonus in performance would require a recompile for PS5 Pro. And as I said, having two versions of each compiled piece of code would create more work than we're comfortable asking the developers to do.
Okay, yeah.
Here, then, are the correct stats for PS5 Pro. It's pretty simple. PS5 Pro has 30 workgroup processors, which is 67% more than PS5 has. So the flops should be 67% higher as well. If we assume a pretty common operating frequency of 2.17 gigahertz, the math works out to 16.7 teraflops on PS5 Pro.
Okay, so maybe this isn't so much of that, oh, the console's not selling, and this is more of like, okay, there is people who think they are know-it-alls on YouTube and Twitter and, this, that, and the other thing, and they are putting out false information on this stuff that is not at all, that's... respect on Sony's part, respect on Mark Cerny's part for actually calling this shit out and getting the numbers straight and everything of what we're working with here. So they went from 18 to 30, the nice round out number here. 64 flops, clock speed, 2.17 gigahertz. All right, so same clock speed. I will say, I'm pretty sure they're talking about CPU here. If it is 2.17 gigahertz, I mean, that could be faster, but then again, AMD parts, Intel runs at 5, 5.2 sometimes. If it needs overclock, I do believe it starts at 5.0 and then it can overclock up to 5.3, which is awesome if you have, just more stuff going on in the background or system, operating system and this and that, the other thing. So 16 teraflops. Yeah, more flops does not equal more performance, but yeah, I think it can probably help out more. So if you have, so say you're recording or streaming from the console, and there's a lot of ray tracing and everything else going on in the background of the console, then maybe I would think the console should be able to run a little bit smoother in that. So just performance overall.
Of course, teraflop numbers are pretty meaningless. What isn't meaningless is the performance of the PS5 Pro
Yeah.
GPU. 67% more workgroup processors means that we can create synthetic tests that show 67% faster processing. In practice, though, there are a lot of factors involved, such as memory bandwidth or even how a particular game engine responds to the details of the new architecture.
Yeah.
So a game team might be looking for something more like a 45% increase in rendering speed.
Good.
That's still a huge improvement, though. At that performance, it means that if a game is running at 60 FPS and is taking 16 milliseconds to render on PS5, then that same frame could be rendered in 11 milliseconds on PS5 Pro. That leaves 5 milliseconds to do something new and exciting, like adding ray tracing, which is the second of our 3 key improvements on PS5 Pro. There's a passion in the game development community for ray tracing. Even in 2020, before the launch of PlayStation 5, we could see creators using ray tracing to add reflections and improved lighting to their games. At the same time, calculation costs for the rays were pretty high, so when we kicked off development of PS5 Pro later that year, one of our top priorities was finding ways to accelerate that computation. Those conversations with AMD led to our very nice feature set that's showing up here first. Note that there's 2 factors increasing the performance. It's not just that there are 67% more workgroup processors. Thanks to the new feature set, each one is more capable. It's difficult to quote an exact speed up because it's very dependent on specifics of usage.
I think this is all due to PSSR and being able to do, because, every single system works together. I'm pretty sure he's going to go into the fact that PSSR is helping upscale everything, so you can actually render at a lower. You can initially render at a lower resolution, so there's not so many pixels on the screen, and then it can add the pixels in where the pixels should be to basically blow up the image essentially and make it fit 1440p, let's say.
But we commonly see the calculation of the rays occurring at double or triple the speed of PlayStation 5. The most impactful new features in PS5 Pro relate to a new acceleration structure and stack management in hardware. There's a lot to unpack here. First, let's talk about the improvements related to the acceleration structure. In order to use ray tracing on PlayStation 5, you need to have data in system memory that describes your geometry, say 1,000,000 triangles worth. Then there's something called an intersection engine inside each of the workgroup processors that lets you check to see if a ray hit any of those 1,000,000 triangles and which it hit first. It would be too slow to test each ray individually against all 1,000,000 of those triangles, so there are also boxes in the data structure. These boxes let the ray tracing hardware more efficiently home in on the triangles that might be intersected. For example, we can see that the ray misses that upper left box, so there's no need to test the ray against any of the triangles contained within it. The boxes are actually in a hierarchy, starting with big ones and progressively reducing in size. Every time we hit a box, we test against the boxes nested within it until ultimately we reach some triangles we can test against. Together, those triangles and boxes are called the acceleration structure. On the original PlayStation 5, we used a type of acceleration structure called a BVH4. BVH stands for Bounding Volume Hierarchy, meaning hierarchy of boxes, and the 4 indicates that the boxes are in groups of up to 4. The intersection engine can then check a ray against up to 4 boxes a cycle or 1 triangle.
I kind of really wish they had something of a video to go along with it, because I am kind of getting lost in all the numbers and everything with this. Just to see it in action of frame by frame of, okay, so light ray hits surface and because I'm pretty sure that's what he's going into right here. The light rays are reacting to, so if a car is dirty, you're not going to see a whole bunch of shine coming off from it. It literally hits the surface and it goes, oh, okay, so there's dirt, there's whatever, no shine. If it's a window or something and the light hits the window, you start to see bing, light rays bouncing off the window. If a window is dirty though, you'll see it boom, hit that window and it'll disperse the light and everything. I'm pretty sure that's what he's going into here. But unless they have like a video, I'm not quite sure.
Generally speaking, there's a lot more checking against boxes. That's what primarily determines the performance of the ray calculations. PS5 Pro adds a BVH8 option for the acceleration structure, where the boxes are efficiently encoded in groups of 8.
So essentially, it's more efficient. It's just more efficient math that's being happening here. It's like more efficient computation that's happening on where and how the lights, and because lighting is, man, if you add different lighting to something, it makes it look tremendously different. So, yeah, it's like light rays are a huge part of this. If you have a blanket light versus a light that can wrap around something, you're going to get so much more detail on that light wrapping around something instead of it just looking faded, basically, because it fades out the background instead of just zoning in on the object that the light's hitting.
And the intersection engine runs twice as fast. A ray can be tested against 8 boxes a cycle, or 2 triangles. That doubling of the ray intersection speed has a great theoretical impact on ray tracing performance, but real-world cases also need a solution to the problem of divergence. That's what led us to our second big feature, which is
essentially, you can actually see it happening in his glasses right now, like IRL-wise, how light travels through objects where you can see the light is lighting up his face, but then you have, the light rays are hitting his glasses and making that shine happen. So literally what he's talking about, you're seeing right there IRL, and that's what all this computation stuff is trying to figure out, like, okay, how does all this light work? Basically, this is the reason why AI can't really think for itself. It's trying to figure. It's not so much that it's thinking for itself. It is. It's just finding the patterns that should happen.
Stack management in hardware. Before I can explain that feature, though, I have to explain divergence. The workgroup processors handle groups of 32 or 64 items at once. They could be pixels or vertices or rays. This strategy is called SIMD, Single Instruction Multiple Data. So SIMD32 means the same operations are being performed on 32 items. This works very well when all 32 items are getting the same treatment. For example, 32 pixels from a triangle are all reading from locations in the same texture. And then those 32 pixels all need a lighting calculation.
Yes.
This is called coherent processing. There's a difficulty that arises with divergent processing, where some of the pixels need one action taken and others need something else. In this case, it's quite possible that the processing takes twice as long. In the limit, if all 32 items need different handling, it's possible to be dozens of times slower. So when 32 rays are being processed together, the degree of divergence has a big impact on performance.
And there you go. So if it's a bumpy surface, then you're not gonna have as much shine happening. If it's a curved surface, then you're gonna have more lights that will beam back in your face. And a flat surface, the reflection is going to go. So essentially, if you want to make a puzzle using lights or something, so you got to shine a spotlight into a mirror and you're trying to control the mirror where that's going to, beam it into a dot over there in the distance to complete the puzzle or whatever. Like say you're playing Uncharted or, I don't know, Tomb Raider or something like that, or Assassin's Creed or something where you have a lot of those. Essentially, it's going to be working off from ray tracing, and you're going to have a lot more control over. So it's not just going to look like laser beam going ding 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 ding. You could actually have more control over the optical illusion of where the light's going and everything. That could make so much more cooler puzzles and everything in the long run.
Ray tracing can be fairly coherent. When we compute simple shadows from the sun, the rays are all parallel. But ray tracing can also get extremely divergent. If rays are bouncing off of a curved surface or a bumpy object, then potentially they're all heading in different directions. The shader code needed to handle divergent rays on PS5 is reasonably complicated.
Yeah.
Part of what the code has to do is manage a stack. The internal structure of the BVH is quite complex, and each of the 32 rays can be traversing it in a different fashion. On PS5 Pro, stack management is in hardware, which greatly simplifies the shader program.
Okay.
It's shorter, which means it's faster, and since it's handling fewer cases, there's less divergence, which further increases the speed of execution.
Good.
You may have noticed that there are now two versions of the code that are needed, a longer one for PlayStation 5 and a simplified one for PS5 Pro.
So you're basically just streamlining the code into one process instead of splitting it. Okay.
But this need for two versions only applies to shader programs that are calculating how rays travel through the scene. There's typically not too many of those.
AKA ray tracing.
In fact, with some games, it's just a single shader program that needs the two versions. Putting that all together, it's great to have the higher performance, but even better, we're seeing more consistently high performance on PS5 Pro. That consistency comes from the improved handling of divergence. Performance testing on PS5 Pro tends to...
So this is also the reason why when you run ray tracing on the regular PS5, the frame rate goes down to, like 24, 30 FPS if you're lucky, because it's got two separate bandwidths of code that is trying to compile together to figure out what the fuck does this actually look like. So the way that the Pro is working, you can actually simplify it into one line of coding, and then it's just trying to process that. It's almost like running two separate pieces of paper through a machine, and now all of a sudden you got that two pieces of paper on one, boom, and it just reads it. Okay, all right.
To show a good boost for the coherent cases like shadows or reflections off of flat surfaces. But a much nicer boost for the divergent cases. The stack management hardware is really helping there.
Yeah. And again, so this piece of paper would be a piece of glass. This one would be a car or something. So if you have both of them together where instead of it, trying to figure out, okay, how's the light going to run to the glass? How's the light going to run to the car? It can do it all together. And literally, if you're playing Gran Turismo, then you have, when you're in VR, this is the reason why everybody who keeps posting up all these videos of VR of Gran Turismo running, it looks so damn good on the Pro because of the fact of you have the light coming in through the windshield, you have it bouncing off from the hood possibly. If there's chrome on, in the fronts, you have, literally the ray trace video happening bouncing off from the chrome. Then also you have the lights ray tracing through and maybe, blinding you a bit when the sun comes around and hits just the right way. Then you also have the light how much light is coming through so you can see the dashboard and all that stuff. Then you have the lights on the dashboard also lighting up everything in the car. So all this stuff is computing and compiling together, and it's doing all this different, the way that the light is bouncing off and what you see with your eyes. It's trying to compute all that stuff at once. And instead of having the two tracks, it goes into... Makes sense.
Having more consistent performance across a broad set of use cases will go a long way towards easing adoption of ray tracing.
Oh, and the shadows also. So how much, not even so much how much light is there, but also how much light glows to take away shadows and how much shadows should actually be there.
The final improvements to the GPU are for machine learning. There are a lot of uses for machine learning, or AI, whichever term you prefer. Large language models and generative AI are quite interesting tech, but with ML, it's also possible to go after a very specific target, which is to give the games a graphical boost. One of the key ways that can work is that the game renders less. There's 8 million pixels on a 4K TV. If the game renders sparsely, say a quarter of those pixels, it can do it a lot faster. And then the right neural network can intuit how to fill in those gaps and make a high-quality image.
This is why I keep talking about you render less pixels on the screen, so less dots on the screen, and then the PSSR goes, oh, that image doesn't look right. Okay, so here's what... And again... It's not so much that it's learning where all the pixels need to go. It's predicting it. So it's like basically all it's doing is predicting which color goes where. That's essentially what pixels on the screen are. They're just colors. So if it can figure out the grid graph, it's almost like the AI is putting together a puzzle in real time for each frame, and it's like just quicker than that even. And then it just has to do it up to 60 frames or 120 frames, and there you go. It just has to predict where all the colors go.
Another way to think about this, which is not quite as accurate, is that the game renders a smaller, lower resolution image and then uses the neural network to upscale that image. This is called super resolution, and it's part of a whole family of strategies that reduce the work involved in rendering the game image.
And really, they don't even need to go up to 4K. They can just go up to 1440p if they actually wanted to get the most performance out of that. Because I would say PS5 Pro should only render up to 1440p and then use the rest of whatever system resources that needs be. Use that to add more light rays to because that's usually how I run my PC games. Is if I'm using ray trace and I'm trying to basically just render up to 1440p, because that after 1440p it's diminishing return. That's basically when the image looks the best to your eyeballs. Even if it's like photorealistic or whatever, 1440p is still kind of like, live action. Even your movies and everything, they would only really need to render 1440p, and then I mean, movies don't mess around with frame rate, but that's where gaming is a lot different in that aspect. But yeah, like I said, I would go for lower pixel count and higher amount of light rays, and then what you're essentially doing is getting the most pixels on screen that you need, and then also upping the amount of lighting that happens, so you have way better lighting in your games. That's how I would run all these game engines.
There's also frame generation or frame extrapolation, where a neural network inserts additional frames between the ones the game renders.
Yeah.
That can really reduce the choppiness of low frame rate games.
But it adds latency, and it can add ghosting, which is not cool. You don't want latency on your controls. If you do that, then you have that split second. So if you're playing something like a Dark Souls game or something, and you need that really split, or you're playing online and you need that split second timing, you want as many active frames in there as possible. So then if you hit that button, it's going to be right there. It's not going to skip. Your button press isn't going to be skipping over to the next frame. You want it to be like, boom, activated, so you can get, you can make the character move and dance the way you want them to.
Neural networks can also be used to turn noisy, staticky images into smooth ones, which is an issue that crops up frequently, particularly with optimized ray tracing. Having said that, super resolution is definitely the focus of our current efforts. Mm-hmm. It's important to note that high-quality upscaling changes the way we should be thinking about game rendering resolution. Let's imagine 3 games that are rendering at various resolutions. A reductionist view on this is that the 1440p game engine is the best, and that the 1080p game is clearly flawed. But after a super resolution pass, these are all ending up at 4K resolution for display. The conversation really needs to be about what's important: image quality. When game creators improve their lighting or materials, or add ray tracing, then rendering each pixel can get more expensive. Right. And the resolution will drop. They move up on this chart. And that's perfectly fine, as long as the upscaling technology is ensuring that the result is a crisp, beautiful image and not a blurry one. A different way to say that is that high-quality super resolution lets game creators focus on fewer, richer pixels and significantly improve the resulting image quality. It's a world where internal rendering resolution is not the primary concern. That's the world we want to be in.
The only thing that I could really throw any shade on is the fact that we do get a lot of artifacting when using upscalers a lot of the time. So, I mean, if they can figure out how to get... So artifacting means that, like, if you are zoomed in, so say you're sitting there with a sniper scope and you zoom in and you start to see kind of that block look to something, and that's artifacting. The blocky look, and it's not smooth. You'll see it a lot, like trying to think of something that Call of Duty does a very good job at smoothing everything out, so I can't really call out Call of Duty for doing it. Maybe Star Wars Outlaws, when you look through that had a lot of artifacting in it. Assassin's Creed also. Actually, a big one was Wukong. Like, Wukong has artifacting all over the damn place. That's why it looks like such a blurry mess when when you start to like swing the camera around and all that stuff. That was probably, come to think of it, that's probably the worst case of artifacting and just like baked in motion blur and everything happening on the consoles. Even on the PC, it happens too. And that's essentially what they're trying to get rid of is all the blocky look on it. Thing is, with upscalers, you end up having that because AI doesn't know how to smooth things out. It only knows how to add a color to it. And if it adds the wrong shade of that color, boom, you're going to have that blocking happening.
For using these strategies for graphics, the work isn't exclusively ML. The neural networks tend to be preceded by conventional processing and followed by some as well. It's the piece in the middle that's the neural network. More specifically, it's a type of neural network called a CNN, which stands for Convolutional Neural Network.
Okay.
Here's a simplified CNN for super resolution. It's not quite the one we use in PSSR, but close enough for the purposes of this conversation. You can see a lot of images. In the language of machine learning, they're called tensors, but basically they're images with many bytes of data per pixel. The colored arrows are the layers of the network. They are processing those images. There's quite a few of them as well. Let's zoom in on the first layer. Its input is a game image, 4K RGB. Perhaps it's a quickie upscale of what the game rendered. The first layer does lots of matrix math and then outputs another 4K image, now with substantially more information per pixel, maybe 16 bytes describing edges and the like that the neural network found in that input game image.
The fact that it can do this in like 1 millisecond is absolutely insane. It's just mind blowing. The speed at which, I mean, it's almost like quantum computing, pretty much. Just the speed of just like boom, and it does all this within that split second. And even doing that is probably like 2 milliseconds or something. So yeah, it's.
The second layer then picks up the output of the first layer and does a lot more matrix math. The resulting image might reflect some deeper understanding about what the game rendered. There's also layers that reduce the size of the images. Downsizing to 540p or even 270p lets the neural network efficiently analyze larger scale structures in the input game image. As you can tell, there's a phenomenal amount of math going on here. Easily 10,000 operations are being performed on every input pixel. And we need to do that math in something like a millisecond. Consequently, ML hardware needs very high performance, typically hundreds of trillions of operations per second. Note that we don't call those teraflops because they're integer operations. Instead, we say TOPS. There were a number of early decisions we had to make. The very first was deciding where in the hardware we would put whatever would do all of that matrix math.
Live for an hour already? Almost?
Generally speaking, there's two options. One option is to put ML capabilities into a GPU. Of course, that's additional logic so the GPU gets larger. Or one can add an NPU, a neural processing unit. NPUs are brilliant at executing neural networks, but perhaps not so good with the pre-processing and post-processing surrounding the CNNs. The deciding factor was the order of graphics processing within a frame. With this approach, most rendering in a frame is done at low resolution, maybe 1080p. Then machine learning is used to upscale to 4K, and there's no more rendering that can happen until that upscale finishes. So we need to process that neural network as quickly as possible, which is to say, we need very powerful ML hardware. The more powerful, the better. That need for power is what pushed us towards using an enhanced GPU. The choice was either adding a large NPU or making more moderate enhancements to the GPU. The next big decision was where all of this technology was going to come from. When we were starting the PS5 Pro project in 2020, we knew that we would need performant ML hardware and a high-quality neural network for super resolution. But we're not looking for ML hardware that's generically high performance. We need something that's optimal for our specific kinds of workloads. And our typical workload is a lightweight CNN, something that can run in a millisecond or so and has a lot of little layers. Broadly speaking, you can license tech or purchase tech or build tech. But once you're licensing technology, that's what you're doing forever. So in 2020, despite the degree of effort required, we decided to build our own hardware and software technology. I'll start with the hardware. We made a set of targeted enhancements to the RDNA shader core and the surrounding memory system.
So technically, this is actually not AMD tech in the PlayStation 5 Pro anymore. It is 100% custom hardware, like rebuilt by Sony for Sony's needs. And again, this is the reason why I say, like, people argue all the time. Every single time we get a new console generation out, well, you can just take this chip and put it in a computer and build a PlayStation. Well, no, because that's not the chip that you buy from the store is not the one that's in the PlayStation. It is a custom configured and custom formatted chipset that is specifically made for the PlayStation hardware. And it's damn near not even AMD chip anymore. It's just kind of AMD is supplying them with the kind of basis. They are customizing it so much that it's almost just Sony's own patented thing now.
We're calling it custom RDNA, as it is custom hardware created to our design specifications, but within the overall RDNA architecture, and of course, implemented by the RDNA experts at AMD. Our target for the peak computational capabilities was 300 8-bit TOPS, which is to say, 300 trillion operations a second using bytes as input. There's a lot of thought that needs to go into the details of exactly how that math functions, but adding that amount of raw performance is not terribly hard to do. The difficulty is memory access. PS5 Pro has 576 gigabytes a second of bandwidth to system memory. When we compare that bandwidth with the computational capability of 300 TOPS, it's clear that it's easy to be bandwidth limited. Let me give two examples. If we do a computation where we read a byte as input and then eventually write a byte, that's 2 bytes on the bus. And the balance point of the system is about 1,000 operations on that byte. If we're doing more than that, we have a well-designed system. The 300 TOPS is being meaningfully utilized. If we do less than that, though, we are bandwidth bound, and we're wasting some of that machine learning capability. 1,000 operations is a lot. Alternatively, to understand this issue, we can take a look at one of the layers of the network, say the second layer from the example I showed before. Let's imagine we have to read that input image and that it has 16 bytes of information for every pixel. That's about 128 megabytes on the system bus. Then we do our math, say a pointwise convolution, and write the output image, which is another 128 megabytes.
Yeah, DDR6. I'm trying to just upgrade my computer to DDR5.
On the system bus. We are completely bandwidth bound. We're only using something like 3% of our potential 300 TOPS. So we're throwing out 97% of our performance. And those reads and writes are going to take half a millisecond just for this one layer. That's almost half of our budget for the entire CNN. One strategy for getting around these bandwidth issues is to fuse layers. The idea is to read up that input image, process the first layer, and then stick the results somewhere, maybe in fast on-chip memory, where the second layer can quickly and easily get access to them. As a result, we're reading from system memory once and writing once, but now we're processing 2 layers of the CNN and using something like 6% of our 300 TOPS. Still terrible, but an improvement. What we really want here is a fully fused network. That's the holy grail of neural network implementation. With a fully fused network, you're reading the input game image from system memory at the very start, processing all of the layers of the CNN internally on chip, and then writing the results back to system memory at the very end. With bandwidth that low, that 300 TOPS number is finally meaningful. There's 2 problems we need to solve, though. The first relates to the amount of on-chip memory required. There's 8 million pixels in a 4K image. If each pixel needs 16 bytes, that's about 128 megabytes. In terms of on-chip memory, that's a lot. Luckily, we don't need to process the whole screen at once. We can subdivide the screen and take just a piece of it at a time through the neural network. Let's call that piece a tile. Problem solved, right? The difficulty we encounter is that as we are processing the tile, bad data creeps in from the edges, so we have to throw out part of our results. The smaller the tile is, the higher the proportion of data that has to be discarded. There are therefore effective limits to how small we can make the tile, and correspondingly, there's a certain amount of fast on-chip memory that's key if we are to achieve that goal of a fully fused network. The other problem we need to solve relates to the bandwidth of that on-chip memory. Our targets are incredibly high. We'd like many, many terabytes per second. When you think in those terms, everything seems small. For example, we could increase the size of the GPU's L2 cache and try to use that for the on-chip memory. But unfortunately, the L2 bandwidth is just a few terabytes a second.
Here's the thing also. Every time they add more bandwidth, add more resource, add more anything to all this equation, the price tag goes up on the console. So they have also to keep it within a certain kind of price tag that they're, so then Sony's not taking too much of a hit, because they're going to take hits on this. But yeah, you got to be careful with that.
This memory problem was the starting point for our custom design. From there, it's been almost a 4-year journey. I'll hit a few high points of the hardware architecture, beginning with the memory we ended up using. It turns out we do have fast on-chip RAM in the RDNA architecture with an aggregate bandwidth of 200 terabytes per second. We just need to change our mindset. What we're doing on PS5 Pro.
So he just said a 4-year journey for this, and then he said 7 years on the console itself. So they're looking at the Pro for being around roughly about 3 years then. Okay.
Is using the vector registers in the workgroup processors as that RAM. Each workgroup processor has 4 sets of registers, each 128K in size, and with a bandwidth of over a terabyte per second. 30 workgroup processors therefore give us 15 megabytes of memory at a combined bandwidth of 200 terabytes per second, which is to say several hundred times faster than system memory. Of course, the roadmap RDNA's architecture and instruction set required some modifications to take better advantage of that register RAM. We ended up adding 44 new shader instructions. Those instructions take that freer approach to register RAM access.
And this is the reason why AMD is trying to use PSSR as a kind of blueprint for running AMD ray tracing on the PC. So for all you PC Master Racers out there, they're like, oh, the consoles suck and this and that. Well, actually, half of your technology that's coming to your AMD chips are actually from the PlayStation, figuring this shit out.
And also implement the math needed for the CNNs, which is primarily done in 8-bit precision. These instructions are specifically designed to operate in a takeover mode, where each WGP processes the CNN for a single screen tile. By the way, the 300 TOPS number has been a real mystery since it leaked early this year. No one on the outside has been able to derive that number from the workgroup processor count and the GPU frequency. The secret is that there are instructions that perform 3x3 convolutions. Those use 9 multiplies and 9 adds for a total of 18 operations. And at that pretty common GPU frequency of 2.17 gigahertz, the performance really does work out to 300 TOPS. Here's the math.
Here's the math. You YouTubers get fucked. You don't know what you're talking about. Damn. So fucking Mark Cerny is coming for people's jugulars with this video.
The CNNs also need 16-bit math, so there's a number of instructions for that. These instructions tend to be a bit simpler and more straightforward. We kept the chip area and the cost low for the 16-bit math simply by targeting lower 16-bit performance, because most of the processing in these CNNs can be done with 8-bit operations. As for 32-bit math, nothing in the CNNs particularly seems to need it, so we just left it as is. Our custom RDNA solution also involved a number of additional features, which I'm going to skip over so I can get to the other half of what we built, which is the neural network for super resolution that we created to run on top of that custom RDNA architecture.
Okay.
PSSR is an original PlayStation design.
Cool.
The full name, of course, is PlayStation Spectral Super Resolution, and that spectral is branding. It doesn't refer to any particular aspect of the algorithm. Just like we have Tempest for...
It looks cool on the box, so that's why we called it that.
audio tech, we're using Spectral for our ML libraries for graphics. One of the project goals for PSSR is ease of adoption, so it uses essentially the same set of inputs as FSR or DLSS or XeSS. Those strategies use the pixel color of the current frame, but also depth information and motion vectors that give the flow of the pixels between the previous frame and the current frame. PSSR is not quite a drop-in replacement for the other strategies, but it's close. Having said that, PSSR is designed for consoles, so its primary use case is a little different from the others. PC games tend to render at a fixed resolution and with frame rate that varies based on scene complexity. Gaming monitors can handle that variable frame rate. So a typical PC game scenario is render at fixed resolution, upscale by a fixed 2:1 ratio, display at fixed resolution.
Right.
In contrast, console games tend to have a frame rate that's fixed because they're displaying on a 60 FPS TV. What varies is the rendering resolution. If the scene is complex, then the rendering resolution is lower. If the scene is simpler, the rendering resolution is higher. Since the display resolution is usually fixed at 4K, PSSR needs to handle a continuously changing upscaling ratio. That scenario is primarily what we design for and train for.
Just so again, when I said before about like when I did Silent Hill 2, I'm like, okay, I'm gonna test something. So basically what I did is I run Silent Hill 2 like a console would run the game engine, to where I fix it to 60 FPS, try like hell to hit that, and then once I fix it to 60 FPS, then I start tweaking the other settings around the game engine. A lot of people will go in and they'll go straight for, okay, I'm gonna turn the ray tracing off. I'm gonna shift up and down the high, medium, low settings on that, and I kind of tackle it like it's a console basically, and trying, okay, what's the smoothest that I can make this run, because also that's the most active frames I can get. So then if I need to hit that button, boom, I can get out of the way of things. I can do stuff so it doesn't feel like I'm getting screwed over on the controls, because that just pisses me off the most. So fix that problem first, then go in and make, just bump up the settings a little bit by a little bit, and see just how fancy you can make all the lighting and everything look. So essentially, yeah, I'm PS5 Pro is basically working the way I have been starting to work with PC, which is really, really cool to see, because that means you're squeaking out as much performance out of the game engine as possible with that.
Of course, PC games are increasingly supporting variable rendering resolution, and all of these upscaling strategies can handle fixed upscaling ratios and variable upscaling ratios. I'm just pointing out that the focus with the PSSR project has been a little bit different.
Yeah.
So with those goals in mind, starting in 2021, we considered a lot of types of neural networks. They were all recurrent networks, which is to say, they feed some of the results back in as inputs. For what it's worth, we looked at flat networks that just run at the display resolution, networks that run at the lower rendering resolution with a final bump up to display resolution, autoencoders that step down the resolution and step it back up, and UNets that do the same, but with different connectivity. And that's where we ended up. PSSR is a recurrent UNet. We also learned just how much work remains after a network is chosen. We did a lot of training and then did beta releases to select developers and got to see all kinds of issues cropping up once PSSR was actually integrated into games. And that required yet more training passes. Some of those issues were trivial. We found out that one game used a perfect blue in its sky, and PSSR had never seen perfect blue in its training. It had no idea what to do with it. Of course, some of the issues we encountered were much more complex. Looking back at the 4 years since we started this project, I'm so glad that we made the time-intensive decision to build our own technology. Results are good, and just as importantly, we've learned so much about how AI can improve game graphics. It can only make our future brighter.
This is essentially the same thing of like whenever you hear people like how I've said over and over again, how From Software should make their own updated game engine to run on all this stuff. And I think I 100% see that. Like if FromSoft does get purchased by PlayStation, I don't see why they would not actually go through and update and upgrade their game engine to be able to do just more with everything, so it would look way smoother and all that stuff. It's essentially also how I think it was MT frame rate or MT network framework, whatever it was called there, that Capcom used to work with. Now they run everything on RE Engine. And you've seen like it's not hard to see the difference on that because the graphics got so much better. You can do photorealistic to art style and everything else, and it scales really easily to all the newest platform stuff that they're trying to do. Like you can scale it from a PC to a Nintendo Switch up to a PS5 Pro, and it just looks great. It runs pretty damn smooth and everything. So essentially, that's what they're doing here with the PS5 Pro. Is they've essentially rebuilt their game engine, if you will, with PSSR.
So that was the background and details of our improvements in these 3 key areas on PS5 Pro: the larger GPU, the advanced ray tracing, and the AI-driven upscaling. I'm going to restate those 3 somewhat, and then I'd like to take a moment to do something we very rarely do, which is talk about the future. Specifically, I'd like to talk about the future potential in each of these 3 key areas. First, there's
this Mark's already just freaking nerding out on this stuff.
rasterized rendering, by which I mean the conventional rendering strategies that were all we had up through PS4 Pro or so. There's not a whole lot of growth left here. It mostly has to come from making the GPU bigger or memory faster. Ray tracing is different. It's still early days for the technology, and I suspect we're in for several quantum leaps in performance over the next decade.
Yeah, very true.
Machine learning, though, has the greatest potential for growth, and that's an area we're beginning to focus on. Some of that growth in machine learning will come from more performant and more efficient hardware architectures. The ML architecture in PS5 Pro is quite good, but we did not, in fact, achieve that holy grail of a fully fused network when running PSSR. It's close, but PSSR can't quite keep all of its intermediate data on chip, and therefore does, to some degree, bottleneck on system memory access.
Interesting that he would actually admit that instead of it being like, this is the perfect thing, this is the best thing ever, and this is it's only going to get better from here. Yeah, he's actually being completely open and transparent with everyone there. Very good.
We see definite room for improvement in future ML hardware. An additional source of future growth will come from more sophisticated neural networks. When fewer higher quality pixels are combined with the right neural network, the result is richer graphics. One way to look at this is supportable upscaling ratio. If we're able to create quality imagery with a 2-to-1 upscale, and can then improve the neural network and reach the same image quality with a 3-to-1 upscale, then the effective power of the GPU has roughly doubled.
So I'm thinking, I might be wrong on this. I'm thinking we should be able to get software updates to end up making the neural network run better, because you'll just have, you can change the way the coding on it. You can basically update the network to be able to predict where each color goes, each block, how the efficiency, there we go, the optimization and efficiency of the software itself that is trying to upscale all this stuff. I would think you should be able to get system updates and do it software updates that way, and not have to be like, okay, here is PS5 Pro 2.0 or something. Or maybe that might be the future with the PlayStation 6 also. So the PlayStation 6 is very AI driven, which I think everything is going AI driven. The AI is basically it's on the level of like the internet being made. It's just a tool that you use that you can use for everything.
And that stacks on top of whatever is being done to speed up rasterized rendering or ray tracing. There's enormous potential here. We also hope to be heading towards multiple uses of these CNNs within a frame, not just super resolution, but also some of the other targets I was talking about, such as the denoising that's needed when doing optimized ray tracing. Through PS5 Pro, we've developed some good understanding of hardware design for machine learning, as well as neural network design, and we intend to continue this work with a pinpoint focus on games. Of course, as part of their broader strategy, AMD is pursuing many of the same goals.
Yeah.
And so I have some very exciting news to share. We have begun a deeper collaboration with AMD. For the project name, we're taking a hint from AMD's Red and PlayStation's Blue. The code name is Amethyst. With Amethyst, we've started on another long journey and are combining our expertise with 2 goals in mind. The first goal is a more ideal architecture for machine learning, something capable of generalized processing of neural networks, but particularly good at the lightweight CNNs needed for game graphics, and something focused around achieving that holy grail of fully fused networks. In going after this, we're combining the lessons AMD has learned from its multi-generation RDNA.
Wait a second. AMD, that is oops, that's not what I'm trying to do. Headquarters in Santa Clara, California. This could also be the reason why, because I'm pretty sure Nvidia is in headquarters is also Santa Clara. Okay, never mind. I thought Nvidia was like Thailand or something like that. Man, why would you go with Nvidia? I mean, I guess it's just, you know, the contract wise. That's what this whole thing runs into. It's just contracts of which company wants the contract more with PlayStation.
A roadmap, and SIE has learned from the custom work in PS5 Pro. But ML use in games shouldn't and can't be restricted to graphics libraries. We're also working towards a democratization of machine learning, something accessible that allows direct work in AI and ML by game developers, both for graphics and for gameplay. Amethyst is not about proprietary technology for PlayStation. In fact, it's the exact opposite. Through this technology collaboration, we're looking to support broad work in machine learning across a variety of devices.
Okay, aka AMD is like, we will do this deal with you if we get to use it in our PC chips also. And Sony's like, fine. And I think the reason why is because PlayStation games are coming to PC, so PlayStation has no real there's no real need to keep the technology all to themselves. They can actually put, if anything, this just makes AMD possibly have a better future. If I mean, it's still like Mark just said right there, they are still one step behind of the Holy Grail. And that's kind of where DLSS has been already hitting, is the best of both worlds on everything. So your PC is still going to be kind of the top-notch technology just because it's more flexible, where AMD is always kind of that one step behind of Intel and NVIDIA. But who knows, with, you know, with Sony and AMD working together like that, you could have something, you know, that could rival NVIDIA and possibly surpass it in the future, especially if NVIDIA starts having a lot of problems in the future and whatnot, with all this like China stuff and Thailand and all that stuff, where, you know, the chipset factories and all that. Who knows?
The other goal is to develop, in parallel, a set of high-quality CNNs for game graphics. Both SIE and AMD will independently have the ability to draw from this collection of network architectures and training strategies. And these components should be key in increasing the richness of game graphics, as well as enabling more extensive use of ray tracing and path tracing. We're looking forward to keeping you posted throughout what we anticipate to be a multi-year collaboration. Let me get back to PS5 Pro for one final moment. You've now heard a bit about our fairly intense last few years building this console and developing PSSR. There's been so much learning for us as we delve into these new technologies. But the payoff, as I said in my PS5 tech video a few years back, is in the games. And by now we know to expect the unexpected. It's an absolute guarantee that the development community will grab a hold of this technology and move in a direction that we never could have anticipated.
And that's what I'm looking for right there, is what's the first thing that's going to make me go, damn, I need to get a PS5 Pro? Essentially, that's the fence that we're all sitting on.
Personally, I can't wait to see what they do with it.
Sure.
Thank you for your time today.
PlayStation.
That was an awesome breakdown. It's really funny seeing that Mark Cerny just basically calling out everybody on, like, yeah, the people just put out rumors. That's essentially. I'm not going to watch this whole thing.
We've gone hands-on with PS5 Pro. Spectral super resolution. There has been a little bit of a difference in terms of approach between some developers like Naughty Dog and some other developers like, for instance, Square Enix, in terms of the kinds of modes that they're offering. So some developers are basically offering many, many modes, many, many toggles like Insomniac, whereas other developers are using PSSR as an opportunity to basically homogenize their existing modes into one ultimate PS5 Pro mode with all the high frame rate fidelity that people are looking for. So what's your kind of position on managing these two things? And do you guys have kind of a way of thinking about that or a preference for certain titles in terms of targeting those different aspects?
I mean, my preference is that the game developers do what they feel is best for their titles. So this is really a question for Mike.
Yeah, I'd say, when we make a game and we work as a whole studio and team on delivering it, we're making some really tough trade-offs between what we want to present at a higher frame rate and what we can present at a, the 30 frames per second lower frame rate. So the nice thing about
you can see the lighting right there of Spidey is way more like you still got the shine there, but the lighting is just bouncing off from everything way more accurate to the way it should be. You can also see more detail on the ground over there. Okay, it's not so much in the background, but so the reason why this background is still blurry though is most likely it's they got the what the hell's it called? Not vignettes, the shit, I can't think of what it's called. The the blurry effect. I can't think of what the hell it's called. The camera effect, the where it blurs the background out and keeps everything in front because it makes it stand out more. I hate that shit. I'd rather have more performance on the frame rate than that.
Being approached with new hardware is that suddenly those compromises we made while shipping the
I mean, look at this. Jeez, night and day difference, literally.
game go away. And so we're able to bring together a lot of what made the fidelity mode on the base PS5 and what made the performance mode
Right.
on the PS5 Pro.
Yep.
Now, after spending some time doing that and having a really nice performance pro mode together, people's attention start to turn to, well, maybe some people still want to play at 30 frames per second. We do have this nice new piece of hardware. What other fun things can we do about it?
Yeah, so I think it probably does depend a lot on the game because for you guys, you have so much ray tracing in there that you can pack into all kinds of different configurations. Whereas I think a lot of developers are going to be in a position where it's well, we can deliver a good 4K image. Now we can deliver it at 60 FPS. Maybe that's the way to go with just one mode, right?
Yeah, I think so.
Yeah, and I knew there would be a lot of different strategies. I was upfront about this in that first video I did, is there were 6 games that were shown. And the first 3 is you can do the almighty mode. And then here's 3 other titles that do something completely different.
Okay, I also wanted to ask just another question about PSSR.
Not only for the game developers, but also for the users that are just depending on what your monitor is, do you even have a 120 FPS monitor versus a 60 FPS monitor? Because most all monitors nowadays, they go to 60 FPS at least. Even your 1080p ones are that's borderline 60 FPS. It's very hard to find a TV unless it's a 10 plus old, even that 15-year-old, TV that does not do a 60 FPS, something or other. I mean, even the old box TVs could do 60 FPS. If you go back to Sega and all that stuff, Sega Genesis, Sonic was running at 60 FPS back then. So
we've seen from developers that there have been a wide range of upscaling factors that are going into this PSSR process.
I'm actually trying to find a difference in this. I think Alan Wake is kind of a bad example on this because I don't see so much just doing this and not zooming in on it. I don't see too much of a difference here, but then again, Alan Wake looks pretty damn good no matter which way you go with it.
We've seen in a title like Alan Wake that's doing 8.
Actually, you know what it is? You know what the Alan Wake thing is? Is this. So you see how it's just, this is just ever so slightly smoother. Again, that's the biggest way to see the difference in just frame rate wise is slow it down. And then you'll start seeing the slower you go with frame by frame, the more stutter you start to see.
P or 1584p to 4K. Is there a kind of guidance that you have?
Oh, So what I was saying about the blockiness, you start to see it a little bit, and depending on how much pixel grid that you're rendering, depends on how much blockiness you're going to get. So there's a lot more smoothness here, and it's because of the fact that, and then it just disappears over here, and that is the fact that it is PSSR on the Pro that's actually filling in where those colors should be.
With regards to those upscale factors at the moment, is there a kind of preference from the Sony team, or is it kind of like roll your own, see what kind of image quality you get, and that ultimately is the thing that should decide your approach?
I'll talk a little bit about the tech we're developing, and then you can talk about how you're using it. There's a lot of research going on there. We support one mode that covers a range of 2 to 5 to 1 to 1 to 1.
Okay.
And whether that's an ideal long-term strategy or not, we're definitely talking about it, and we're looking at the low end of the range and the issues we see there versus the high end of the range.
Today I actually want to try and start up a couple hours of GTA 5, and everyone that's like complaining about, oh my god, GTA 5 could use ray tracing. GTA 5 could use ray tracing and everything. It's like, well, can the game engine even do that? Does the game engine even know how to implement that? Because that's a whole other, as he was just saying, like that's a whole other code set that you have to implement into already what is running. And it's an already old engine to begin with. Like, this is the reason why Rockstar is like, oh boy, they're going to need to upgrade the Rockstar game engine very soon. Same thing with From Software. What's the other one? There's one other one that's going to have to upgrade. Like Konami just did it with their game engine. And that's going to be the thing of like going forward with AI stuff. You're going to have to make sure that you can implement AI into everything. Again, I don't want to do too much with that because I've already been sitting here for like an hour. Update. Okay. Can it be a patch update?
Of PSSR, perhaps? Like, we know that so far there have been some improvements in that PSSR iteration over the time pre-launch. So will that continue in the future, do you think?
I mean, we're definitely continuing with development of these ML-based libraries for game graphics. It's just that there's so many targets to go up against. Like, I was in that talk today, I was also going over frame generation, frame extrapolation, ray tracing, denoising, and the like. So what order and what focus, those are really good questions. Additionally complicating this, of course, is that we announced Project Amethyst with AMD today. Right. So it's not just us developing the networks. We have a partner that we're doing it with. And of course, what the partner feels about that technology direction and where the focus should be is also very important.
Okay, so in that vein, on PC at the moment, we have a lot of technologies, like you mentioned. We have frame generation. We have lots of AI upscaling models. We have people even talking like Intel about possibly frame extrapolation models. We also have models like DLSS ray reconstruction, which are doing pretty profound things to the makeup of a game image in real time in a pretty lightweight manner. So these are areas that you're possibly exploring. Is that what you're saying for future PSSR upgrades? Is that what you're thinking about?
Oh, definitely. Well, it wouldn't be PSSR. It would be, so PSSR is PlayStation Spectral Super Resolution.
So it'll be different branding. Yeah, Spectral's branding.
Spectral is our branding for the ML libraries for graphics, just like Tempest is our branding for our 3D audio.
Right.
And so it's going to be Spectral something for all of that. And yeah, we're definitely looking at what it would be that Spectral something, if not Super Resolution. But Super Resolution is a very good place to start.
Right. And then in terms of that PSSR, in terms of the way that it's implemented on a per game basis, that's something that developers will presumably have to go and patch in new versions of PSSR, right? Because you wouldn't necessarily want new versions of PSSR kind of in the mix there without a title update, or is that something you're thinking about?
Well, there are a lot of interesting possibilities there. And I know, honestly, I don't know at this time. It's wonderful to think that the game could say it's okay to update, or a user could make a decision to update. Just how all of those pieces fit together, I don't know.
From a developer perspective, I think we can look at our games differently a lot of the time. And I know some developers would say, I don't want the system to touch what I have confirmed looks good to me and players. And other developers would say, oh, your system's going to go and make my game look better for people without me having to do anything great.
Okay, so see, this is the blockiness again that I'm talking about. Like it game looks good on PS5, but it can actually smooth out. You still got the blockiness there, but it's nowhere near as bad. Like this looks blurry because it's blocky. It looks blurry, but it's not. So like you still got, you can actually see the whole thing where there's just like the green is missing over here, where you got the actual green being filled in and everything. It's the little details like that, but still, you know, if they can implement more and more upgrades on that and get more and more of the colors where they need to be, then cool, then awesome, yes. And
so there's options there.
Yeah, I think with
I mean, look at this. You actually see full on grass, where this is just a kind of a garbled mess over here.
PSSR, a lot of people are pretty interested in a certain kind of problem, which is that you have a pretty tremendous improvement in image quality. And I think we see this across, you know, different kinds of PC upscalers as well when we're talking about that. But the internal resolution of that imagery might not be changing that much relative to what you saw before. So are you guys...
I mean, look at this. It just... this looks like an oil painting. This looks like a photograph. You know, it's
kind of trying to figure out how to message that to people and tell people like this is a profoundly improved image despite the fact that the internal resolution is comparable. And I know that we're part of this problem for sure, so that's a tough thing to message. But have you thought about that?
You're not part of the problem. And I've heard you talk. I spend too much time on DF, but I've heard you talk about how you really shouldn't be looking at internal rendering resolution and drawing too much in the way of conclusions from that. You really need to be looking at image quality. And I was trying to communicate exactly the same message today, is we need to change the way we're talking about resolution. Maybe we shouldn't be talking about it at all. The difficulty is if you don't have a number, right, it's very hard to have that conversation.
Yeah, I think we tried to get away from it at some point by just maybe stop telling the numbers and start using like some kind of model that would tell people what the approximate image quality is. Yeah. But it's a big challenge because like you're trying to communicate different.
Jeez. I need my glasses on. Bam. Okay, I can see something now. It's like shit. That's the upscale right there. Like holy shit. It's like, you know, Spider-Man back in the day. What? I can't. Oh, there we go. Man.
Different things, and resolution is an important part of that at the moment, at least. But that final image is ultimately what really matters to people, and I think that's what
I need to reload up Rebirth again and actually look at that game, because it's been what, a year or so since Rebirth came out, and I wasn't even noticing it so much when I was playing through it the first time, because you're trying to check menus, looking for shit on the ground that's right in front of you and everything, just to be able to notice how, because I don't remember it being that blurry, but then again, it probably is, and I just didn't notice it.
We're seeing with PSSR for sure. One last question about PSSR here, and this relates specifically to your work, Mike, is that one thing we saw with PSSR in Ratchet and Clank in particular is that it appeared to improve the stability and resolve of RT reflections. Is that something that you see?
Okay, hold on. Let's oh, okay.
With no experience whatsoever.
Yeah. One interesting thing about the PS5 Pro, it's obviously being upgraded in a ton of respects. You've got improved memory, improved storage, obviously a massively improved GPU, but the CPU is staying roughly the same as we had before. Now, there is a clock bump that developers can tap into there, but it is, broadly speaking, a very comparable CPU there. Why wasn't the CPU upgraded, and why was not such a big focus there?
It's really just a question of where you put your resources. And I wasn't seeing, and I didn't think I would see, that many titles that couldn't run at 60. That's kind of my litmus test. Yeah. I'm not asking do all the games run at 120 at this point in time. I'm asking do all the games run at 60. And you can count the AAA exceptions on one hand, I think, for games that didn't eventually run at 60. And so it seemed if we threw pretty much all of our resources into the graphics, that would be the best approach.
Right.
And say as
Jeez. Damn. That looks details on. That's cool.
As a developer, the day Mark comes and says, "Hey, we want to give you guys a presentation about what we're thinking about for the next hardware," like that's a fun meeting for everyone, and we were very happy with where the focus was here, GPU wise.
Yeah, with regards to the machine learning hardware in the console, do you essentially see that as kind of a solution for a problem that we're seeing across the industry, which is that you don't get good cost scaling on new silicon nodes anymore? You aren't getting that massive driving down in the cost per transistor that's enabled us historically to increase the power of consoles. Is machine learning ultimately, is that going to be the answer to that question, do you think?
Yeah, I mean, hopefully everybody watches that video that we're talking about, because that's precisely what I was saying is rasterized rendering, and I don't have a better word for it, but the strategies that we had up through PS4 Pro or the like, that is, I wouldn't say it's reached a limit, but mostly it's about making the GPU bigger or memory faster. And so, as we look to the future, the improvements will be ray tracing. Ray tracing, I think we're going to see a lot happening there. And then everything we can get done with ML.
One last question here on the PS5 Pro hardware itself, the way that it's been configured. We seem to know roughly that you're targeting similar clocks in the GPU as in the base PS5 model. And you might have some issues possibly with running up against power constraints in this model in possibly a more significant way because the model itself has a much larger GPU. So is it the case that maybe developers will have to deal with a little bit more of a variable clock speed in that GPU?
That's a great question. It's pretty much identical. So PlayStation 5 capped at 2.23. PlayStation 5 Pro caps at 2.35, which I did not talk about in the video today because it's just such a distraction. I don't want anybody doing flop math based on 2.35 because at the end of the day, we go in and when we do the set design, we tune the set design so that the games are running at about 2.17. Right, we don't want to get too bulky. We don't want to have the fan have to be too large or the like.
Right.
So, I mean, that 2.35 is really a red herring. I don't think too many games will get up to that too often.
Okay. I just wanted to ask some more, I guess, general questions and maybe a little bit more.
Okay, what if they go full realistic though with it, and Here's the other one too, is like AI. It seems to be like AI is really focused on making photorealistic stuff. So I wonder if photorealistic is maybe actually easier for AI to render upscale than it would be for something that has like an art style to it, for example, that isn't as easy to. Okay, so this is person, but this is thing with giant ears, a tail, and everything else. I wonder if the AI is, if there's a difference in that, basically trying to figure out where the colors and the pixels all go on something. Guns all look relatively the same. You have a handle, you have the barrel, you have a trigger, so it can render that more easier. And upscaling HUDs and everything is super easy too, because all HUDs are pretty much the same thing.
Philosophical questions possibly from this point onwards, because
generational hardware leaps. Ooh.
Philosophical questions possibly from this point onwards, because I think we've seen from your presentation that you have a really clear vision for what the PlayStation 5 Pro looks like. And obviously you've delivered a compelling piece of hardware there. But I do wonder a little bit about something in the presentation, which is that you kind of positioned the PS4 and the PS5, then the PS4 Pro and the PS5 Pro as existing along separate tracks. One down the left-hand track as generational leaps, and then the mid-gen refreshes on the right, the enhanced consoles. Now, we're in an era where developers are shipping cross-gen more than they ever have. But does that chart reflect that you still believe fundamentally in generational leaps, going from one generation to the next generation, big changes in software, big changes in what people can deliver on that hardware?
So we're not making PCs. We're making a few very specific things, right? How many types of PCs are there? I mean, you can't even answer that question because you can combine the components in any way you want to. So the Pro consoles are very tightly targeted. I mean, you're seeing around GPU. But when a new generation starts, then it gets opened up to what are we doing with the CPU? What are we doing with the amount of memory? What are we doing with haptics? It's a whole new experience that the developers can go out. And I think it's really helpful, even if we drop words like revolution from the conversation, I think it's really helpful if the developers have that thing to consider and can ask the question, okay, this game, yes, it'll ship on one, it'll also ship on the next, but how can it be a different creature for each of those? Not gameplay-wise, but in terms of the visual experience.
Right.
Good influence.
Yeah.
I think what consumers are really looking for, though, is because this is what I see the most of. Wait, what can I do on this thing that I can't do on the next thing? So visuals are going to be like, you know, we're way past the whole thing of going from like polygons to you know, lumen and all that stuff, you know. So I think again, the biggest generational leap is this damn controller, because it's vibration, it's, you know, it's gyroscope, it's, you know, the vibration on that, but also the biggest thing that changes with this is it's not just rumble, it's not just, you know, swinging a weight in there. It's actually using audio to push a vibration through this, so you're using way more data there, instead of it just being like, okay, just spin the tumbler inside there, so many rotations and whatnot for this, you know, big boom, and it swings. No, it's not that at all. It is, if you hear a boom, that boom gets translated into vibration data, which then you feel in the palm of your hand of, and so you have way more of, you know, one gun feels different than the other gun. One explosion feels different than another explosion. Water, sand, dirt, that all feels different in the vibration that happens in this. So again, that feels like the most generational leap that we've had. I think that's what everybody's kind of looking for. The VR thing, you know, yes, it makes people sick, but at the same time, what else is there like that? And right now, there is nothing else like a PlayStation 5 DualSense controller, because nothing else is using vibration. Everything is using still rumbles or tumblers in there. So I think that might be something that I'd be a little worried about. I mean, you know, I think we're good. All right. Let's check out Exodus, and then we have Intergalactic, and I might stop the stream for a little bit and just keep this as one stream, as like the Let's Talk stream, and then maybe come back a little bit later and do a GTA 5, because I want to run through GTA 5, the full story mode on that, and then also run through Red Dead a little bit later on afterwards. So let's check out Exodus, the gameplay trailer. Let's see what this is.
Preparing to transfer now. This is your last chance to bail, June.
Do it.
This is very Andromeda. So I do believe this is supposed to be the spiritual successor to Mass Effect. This is also made by Casey Hudson. I'm pretty sure. Let's see here. Founders, received founders. The Traveler gameplay prologue intro. News media. Nope, that's news media. Was this the Casey Hudson one? Or did that get shut down? No, wait, no, I think that one got shut down, actually.
Guess what? Today is the first day of our new series, Archetype Access. We wanted to at Archetype.
I'm Chad Robertson. I'm the general manager at Archetype.
Okay.
In a nutshell, I oversee the operations and the budget and all the things that makes the studio
I thought this was a Mass Effect spiritual successor. It's not, but it looks pretty Mass Effect to me.
run. But at the end of the day, the thing that matters the most is I make sure we've got great people that have all the tools and all the things they need to make a great game for our players.
Can you tell me what you like best about being
Okay.
Hey Victoria, how's it going? You mind if I ask you a few questions for our next episode of Archetype Access?
Yeah, sure.
Cool.
So this is to introduce our developers to our fan community and help them learn about what we do here at Archetype as we're building Exodus. So first off, let's start. What's your name and what do you do here at Archetype?
I'm Victoria. I'm a gameplay animator.
Awesome. And so what's with the gun?
Yeah, so I was just trying to figure out this animation that's using the gun. So that's why I came here and tried to capture some mocap.
So this is all to make June a badass in the game and feel super powerful?
I'm trying my best.
Oh, excellent. I can't wait to see it in the game. We're to the speed round part now. I got 3 questions for you. You ready?
Okay.
Question 1, favorite movie?
Lord of the Rings series.
Oh, beautiful choice. I love them myself too. Question 2, favorite game?
Diablo 3.
Diablo 3. Excellent choice. Why Diablo 3 then?
Because I just spent like hundreds of hours playing that game. And it was great memories with friends.
Yeah, I love the social aspect of it. That's awesome. I love it. All right, last question. You're about to go to a deserted island. You've got one chance to get food in Austin. Where are you going to go? What's it going to be?
Probably it's going to be Style Switch Barbecue because I don't think I've had like a good pork ribs until I came to Austin.
Very nice choice. I like that place
they're
too.
in
Excellent.
Austin,
Well, thanks so much for
Texas.
taking the time to talk to me and to our fans. Well, hopefully they'll be excited
cool.
to learn about you and stay tuned for more episodes of our...
Okay. Interesting. Like, if you're into high fantasy, why are you working on spaceship stuff? Okay. Brings a different aspect to it. Definitely feels very Mass Effect. Andromeda, not the original trilogy.
Loaded weapon is a hell of a way to greet your new partner.
So you're June.
We're burning time. Now that we're all best of friends, let's make each other rich. I'm not just here to look pretty. I've got away with celestial tech.
Evil Bear. Okay, so big boss fights.
I see a lot of potential in this new partnership.
How about Resident Evil prize boss fight?
Target acquired.
Thanks to the collector base.
Thanks again for your help.
You should have been honest.
This place is forbidden. The price is death.
That's what it means to be a traveler.
Can we customize the main character? Oh, that's a huge one that makes Shepard what he is. Like, I'd like to see that in this, in that similar vein of like, that's what makes your character so damn good, is being able to do a dialogue tree, customized character, all that. Become the traveler, like, let me customize the damn character then. Looks all right. Looks kind of cool. Like, yeah, I mean, yeah. Wouldn't mind. Archetype, a lot of veteran devs from BioWare and Bungie who worked on titles like Dragon Age or original Mass Effect and Halo games. It looks like it. I'm Garrus for carrying this. My favorite spot next. I would be. This is where Creative Talent Mass Effect 1, 2, 3 went. Yeah, and I'd be very interested to see more on Exodus, see where this actually goes. Cinematic Awakening, cinematic. This feels a lot like Mass Effect, and I'm kind of liking it, but it's I have a hard time, getting hyped up for anything now. I want to like it, but I want to see more. I think I'd want to see another. I think I'd want to see a full mission. Just like one mission or even half a mission, like, something that's like a 2-minute cut of a full mission. Just show me that. But it is very interesting. Just everything that they're doing with this storyline wise, cinematic cutscenes, it looks like it's in there. You got the whole spaceship thing is there, so possibly spaceship crew. This doesn't look like it's as big as the Normandy, so I don't know if you're going to have a full crew in it. They could. I would definitely, again, let me customize the character, the abilities here that we're seeing. It is a lot of shoot 'em up, but I do like the fact that you can jump up on the top piece and then come down and stab the bear in the head and all that. That looked pretty cool. That was very like Resident Evil kind of in a way. Traveling around different planets, figuring out what the hell happened in the different planets and whatnot. Could be cool. Could be cool. We'll see. All right, one last thing, and then I'm going to wrap up for right now. Hopefully I'll be able to get back tonight with some GTA. I was thinking about live streaming GTA 5 story mode because everybody plays a freaking online. Put story mode on the map for once. So announcing Intergalactic, the Heretic Prophet, a new franchise from Naughty Dog. We're back. Been dying. Okay, I just want information. Intergalactic. Jordan A. Munn, a dangerous bounty hunter who ends up stranded on Sephiria, a distant planet whose communication with the outside universe went dark hundreds of years ago. Oh, okay, yeah. In fact, anyone who's flown to it, hoping to unravel its mysteries, has never been heard from again. Jordan will have to use all her skills, in which if she hopes to be the first person in over 600 years to leave its orbit. Okay. When you got a name like Jordan A. Munn, I'm just like, she knows she's a she, right? Pride placement, the game, bald head, doesn't like first looks at the character again just throws me off. Let's see here. Beyond that, we're keeping everything about the story under wraps, at least for now. Lives up to Naughty Dog tradition, create an emotional, character-driven. Rival our gameplay ambitions, deepest gameplay in Naughty Dog history, taking our learnings from previous franchises. Jordan is played by the talented Tati Gabrielle. Wait, does Tati Gabrielle actually have hair IRL? Maybe this is the reason why they don't. Like, no. Has to be a bald character. Wait, you have hair here. You have hair here. She just looks like she's got that, like, kind of bitchy attitude. Will it come through in her performance as the character? I don't know. Does kind of seem like it a little bit. Who leads a stellar cast, unintended. Eagle-eyed players might spot some other cast members in the trailer. Reveal more ensemble time. Yeah, that dude that tries to be in the hero movies. Incredible Voyage in the Cosmos, also equally incredible soundtrack. Trent Reznor, Atticus Ross. Trailer is just a small teaser work. We know you're eager for more, and trust us, we're very eager to show you. For now, though, keep cranking away on Jordan's adventure. Everything in me just like is just my gut feeling is really screaming this in for spoken. And we all know how that ended up because the main character was kind of like rough to listen to. On behalf of the entire team of Naughty Dog, I need to watch the trailer again. Let me watch the trailer again. Listen to this main character because it threw me off so much. Oh, Intergalactic. Let's see if my second viewing of it, if my opinion changes at all. Must be the suffering of generations must be endured to achieve our divine end. Ancient Superior Scripture, 1986. Like they're going for kind of like this Uncharted vibe with it, and then they're like, wonder if this might be the first flop Naughty Dog. You have a studio like Rockstar, and you have a studio like Naughty Dog that's been around for like 30 something years. Never put out a bad game, really. I just want to be able to customize the character. Just give me that, like, even when Max Payne went bald and Sam Fisher went bald, I was just like, why? Eh. It just always bugs me with characters when there's there's a certain, I don't know, there's a certain character look that's just like, you're not Stone Cold Steve Austin. It's really hard to get away with the bald look. She had hair here.
Jordan?
Tell me something good.
Well, you're right, it checks out. He's hiding out around this Imperium moon.
It's just distracting. I'm sorry, it's just distracting as all hell.
Excellent.
How is that excellent? He's next to fucking Simperia. No one has left that planet in over 600 years. Anyone who even flies close to it is never heard from again.
Superstitions.
No. Superstitions are the crazy rumors about what happened on that planet. These are facts.
You worry too much.
You know what I worry just the right amount. I say we wait for him to leave, or how about we find a new lead? He's not worth it. I'm wasting my time, aren't I?
Can you please claim him? I don't need another hunter swooping in.
The body language on this.
Can you please claim him?
She's acting like a fucking high school brat.
How about we find a new lead? He's not worth it.
I'm not listening.
I'm wasting my time, aren't I?
Can you please claim him? I don't need another hunter swooping in.
Who is swooping? No one is crazy enough to go there.
He clearly is.
He is clearly desperate.
And so am I, so claim him, or I will find another agent.
Anyone else with all your fucking shit? Okay, alright, you know what? There, you're the boss.
Yeah, it's the dude that Kunam, whatever his name is there, and it's like he tries like hell to be funny, and usually it's just like, eh.
Thank you.
Listen, kid. I'll see you on the other side.
I just don't want to be doing this right now. It's just, the look and the attitude and the feel of the character is just like, oh God, why? It's just not a likable character. Like Nathan Drake, it brings in because he's, it's kind of that Indiana Jones, like, who the hell is this guy? How does he know all this information? Where did he get that ring? What the hell's going on? Like, it draws you in, and then he's like a smart ass that kind of screws up every once in a while, but also he's, super loyal to his friends and everything. That's cool. That's a cool character. Ellie is, she, as much as she gets her ass beat by the world, she just keeps going because that's all she knows how to do. That's cool. And then also she's just looking out for her friends and also, you know, trying to keep her only semblance of family alive. That's cool. This is just bratty kind of high school behavior. Like, that's just annoying as shit. Like you can see it right here also. Scared shitless. Very unsure of herself. Doesn't know whether or not is like contemplating life choices and everything. It's gotta be like we figured out space travel in the 80s. I think there's a part of me that's also kind of disappointed that like after Last of Us Part 2 had such good gun gameplay and it was so much details in every like stab or shot or anything like that, and now this looks like it's going to be pretty much melee combat focus. I'm just like, oh. Or it's laser guns and you just, you know, like the thing with Ellie, when you're shooting, if you shoot somebody in the leg, they go, oh, they grab a hold, or if you shoot them in like the arm with an arrow, they grab hold of the arrow and whatnot. And then you have like the dogs coming up and rah, 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 and you got to stab the dog. It's like there's so much detail going on. And the problem with this here is also, how the fuck is she breathing on that planet with no suit on or anything? Maybe the biggest problem with this is it's going to be probably Dark Souls-y combat. Almost guarantee it's going to be Dark Souls-y combat in a way. Whether there's a stamina bar or not, we'll see. But there's going to be lock on, ting, 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 doing all that stuff with boss fight and all that. And it's probably not going to be as detailed because you have that Dark Souls-y combat. Because Dark Souls-y combat, you can't do detail of like, oh, I'm going to slice them into the kneecap and then they're going to start grabbing at their knee or something. No, that's it. You just go into a finisher move with that. So yeah, this is a very rocky start to this game. This first trailer. I do like the throwback Naughty Dog logo. That's cool. And PlayStation. I wonder if this takes place in like the 90s or something. I don't know. Again, Intergalactic, the hard one. It's kind of a hard one to get into. It feels like they're kind of missing the mark with it. I wonder how far along in production all this is. If they could maybe change the behind series. Yeah, Last was in charge. I wonder if they could change up the character model a little bit just to make it more. Again, unless it's like I said on social media, unless she is from a prison camp and she escaped from that, or she has she's been, you know, oh shit, how did I put that? Unless it was a prison camp or she was like a slave of some kind for, you know, on a alien planet or something that she escaped from, where, you know, it's working the junker rig on an alien planet and everybody has to look the exact same. You know, it's like that. Why in the actual fuck would you make her bald? Fix all kinds of, like, don't give her the damn super hairdo. Don't give her the high top phase. Definitely don't make her fucking bald. give her a regular haircut that no other characters out there have. Of that, maybe shoulder, a little bit of a longer hairdo with the actually, yeah. Come to think of it, Star Wars Outlaws, the one thing you can say that character is ugly or whatever else, but the one thing that you notice right off the bat, 80s poofy hairdo is right there. It separates her from pretty much everything else that is out there. Just off from that. Again, the bald head is so damn distracting. And then just her attitude behind that too is just like, ugh. If she had I would say also, if she had a better attitude, she could maybe pull it off more. Like they could maybe pull that character off more if she had a better attitude. But right now it's just given like, I don't want to be here. I want to do this. It's like, who the fuck wants to play that character of just, you're sick of everything. You hate everything. You have a shitty attitude about it's like, yeah. Anyways, like I said, I think that will do it for now. I'll try and come back maybe in an hour or two. I gotta go grab me some food and whatnot, and maybe start up GTA 5. Do like maybe 2 hours of the GTA 5 story mode. I think I'm gonna redo it from scratch. I did already play through it once on stream, half of it. I've never actually fully streamed Grand Theft Auto 5 story mode, so I'm like, screw it. I kind of want to do that and Red Dead for just to end the year out. And we got like 2 weeks, so I'm gonna try and do both of them within that 2 week period. So, anyways, yeah, that'll do it for right now. Hit that subscribe button would definitely help out a lot. Hours watched on the channel too. I'm really trying to at least get 2,000 hours watched by the end of the year. Very close to it. I'm like, it's like 40 hours off, something like that. So go through, check out the rest of the channel, and go and watch a couple of the videos. Yeah. Anyways, it's a lot of gaming news and tech talks and everything else. So yeah, this the stream basically just turned into a Let's Talk stream, and that's pretty much all I touted it for. So again, I'll wrap this one up, and then I'll be back maybe in a little while. We'll see. Again, if you hit that sub button, you can see when the next stream is. So anyways, until then, thanks for tuning in. Thanks for stopping by, and as always, I will see you next time.